function inputs and outputs. Let's dive right into the first example. Y equals negative 3x plus negative 6. Indeed, very sharp observation. I love it, Ramirez. This is the very same one we did for warm-up, and there's a reason why. Excellent. Very same equation. Go to write this down. Example 1, y equals negative 3x plus negative 6. All right, first thing I want you to do. Go ahead and draw an arrow and put it underneath the y, and then draw another arrow and put it underneath the x. Y equals negative 3x plus negative 6. Y equals negative 3x plus negative 6. All right, what is the y called? Well, veteran students will recognize this. Y is called the output. And x is called the what, veteran students? Thank you. Go and write this down, please. A little review. Veteran students, now that we're in higher level mathematics, if you recall, if you're a veteran student in here, instead of writing the output variable, what's a higher way, a higher level of mathematical nomenclature or symbolism that we replace the output with? Medina, save the day. All right, put an arrow now with the output underneath the word output. Going to put f of x. This is higher level symbolism when we deal with equations. Y is a function of x, so I'm going to replace y with f of x. It actually means the same thing. Go to write negative 3x plus negative 6. So that output now, we're not in kiddie math anymore like math 1 or pre-algebra days. We're math 3 students. I'm preparing you for pre-calculus concepts. We're going to use pre-calculus nomenclature and symbolism, which is f of x. Now, what does f of x mean? Underneath the f, going to put function name. In other words, it doesn't have to be f. We can name the function g of x or h of x. You'll see that sometimes. Going to write function name. This is still the input, of course. That and that. It's a different way of writing an equation. So, function name, we got the input. Just as a little FYI, the function names could vary. The function names could have been h of x. Watch this now. I could have wrote this as h of x equals negative 3x plus negative 6. That would have been equally as legitimate. I could have wrote g of x equals negative 3x plus negative 6. These are all equal. They're all the same. They're just different names for the function itself. A function is kind of like a machine. You put stuff into the machine spits out stuff. Remember that one? What was it about? Man, you are paying attention. That's awesome. That's like encouraging. You actually remember so that's cool. Now.
We haven't lost all hope.
True. Watch this. Now, the reason why we can replace y with f of x is because y is a function of x. When I say y is a function of x, what I mean is y depends on x. Recall on the warm-up, I told you y depended on what x is. I said that. Hey, you guys, y depended on x because we're putting x values in here, and y depended on what x was. If something depends on something in the English language, we can say that something is a function of something. Here's an example that's not mathematical. You passing my class depends on your work ethic. That's true, right? You passing my class depends on your work ethic. Now let me rephrase that. Instead of using the word depends, I'm going to use function now. You passing my class is a function of your work ethic. So in the English language, to say that something depends on something else is the same way as saying that something is a function of something else. Can someone give me another example in just real life? Something that depends on something else, and I'll give you an extra stamp.
A gear depends on another gear to make it turn.
One more time.
A gear depends on another gear to make it turn.
Okay, so now rephrase that with the word is a function of.
A gear functions of another gear to make it turn.
Close. A gear is a function of another gear. Sorry. Extra stamp. Okay, someone else give me another example. The Dodgers winning the World Series depends on the left. The Dodgers winning the World Series. The Dodgers winning the World Series depends on Clayton Kershaw pitching well tomorrow. So now let me rephrase that, but instead of writing or saying depends on, I'm going to say it's a function of. The Dodgers winning the World Series is a function of Clayton Kershaw pitching well tomorrow. So, on the warm-up, y depended on what x is, so I can say y is a function of x. It depends on x. That's where this whole function concept comes from. Now, I'm going to write an example 2 now. Evaluate the function at x equals -3, and I gave you a linear function there. Going to write f of x equals -7x plus -21, please. This is example 2. Again, this is all in your graph paper. We're going to get to a graph shortly. All right. X represents an input. We're going to put the input of -3 into this function and figure out what the output is. Watch. It's almost identical to warm-up. Watch this. So I'm going to figure out what this function's value is. Let's look at evaluate, figure out the value of it. When the input is -3, write this down with me now. Watch this. The function at -3, look at this. Wherever I see x, I'm replacing with -3. Is -7 times -3 plus -21. What does Aunt Sally tell us to do first, Leon? Thank you. I'm going to multiply before I add. So look at the function at -3 is negative times negative is a positive 21 plus a negative 21.
They cancel each other out.
Nice. So what's the function at -3 then? 0. So write 0. Notice how I write the final value. The function at the input of -3 is 0. So if we're to plot it, going to give me an x and y axis somewhere on your graph paper. Go and draw an x and y axis, please. But notice I said x and y. Shame on me. It's no longer y. It's now what? What's y? F of x, huh? The y axis will now be f of x axis, ladies and gents, because you guys are advanced mathematicians. The x-axis stays x-axis, but the y is no longer y. We call it f of x-axis, the function at x. Let's plot this puppy. What was the ordered pair? What was my input?
-3 and 0.
Thank you. So this was my f of x. This was a function at -3, and this is my input. Let's plot -3, 0. Do it with me. There it is. That was easy. Notice this is no longer the y coordinate, it's the f of x coordinate. Everything's the same though. F of x, x, for rocking and rolling. Right, -3, 0. Make sure you write that ordered pair and underneath put input and then the function at -3. Put an arrow. These are very important. You need to know what these mean. When you're in Math 1 or pre-algebra and when you're in junior high, you would say y is equal to 0. Now we're saying Well, that's the function at -3. 0 is the function at -3. So it's different. It's kind of like shifting gears a little bit in your thinking. So we plotted 1 point. Cool. Last example. We're done for the day. So far, veteran students in here, you might be asking yourself, I thought Mr. Mungia said we're going to cover something new. Veteran students, you know all this already. Now, put your seatbelt on. Last example, example 3. Evaluate at x equals -1. I got a nasty polynomial function now. Throwing a curveball at you. I'm going to strike everyone out in here. Uh-oh. Let's see. I'm going to give you guys about 3-4 minutes. Whoever evaluates this correctly gets an extra 2 stamps. Hit it. Hit it. All right, here we go. So, the function at the input of -1 is +8. Nothing I've done thus far is brand new to veteran students until now. Watch this. I'm going to show you a shortcut how to get the +8 output. And it's actually something you already know how to do. It's a shortcut though.
What, this little thing?
What was the last shortcut I taught you? What was that called? Synthetic what?
Division.
Believe it or not, synthetic division will help us to get the +8 quicker.
We found out you were teaching us the wrong way the whole time.
Boy, hostile crowd today, man. Jeez. Watch this. This is gonna blow you away. Watch this. Instead of going through all the gymnastics and intellectual rigors of doing all the positive, please excuse my dear and silly steps to get the +8, look how easy synthetic division is to get the +8. It's kind of freaky how it gets the right answer. Watch. Here we go. Help me out, Torres, help me out. Here we go. Synthetic, I'm going to just abbreviate synthetic division, put down your notes. This is the last part of our notes. Look what I'm going to do. I'm going to put the L brace. Watch this. I'm going to put the coefficients of the function. What's the coefficient of x30? That's +1. I got a +2. I got a -3, and I got a +4. Look at what I'm going to do. Here we go. 1, 2.
How is it a -1? I mean a +1 now?
Because there's not a negative in front of it.
Yeah?
Yeah, okay.
Yeah? And then +4. Now, what's freaky about what I'm about to show you is that nowhere in this problem of evaluating the function am I asking you to divide. Yet we're using synthetic division to figure out the value of a function. It's kind of freaky and weird, but it actually works out. Watch.
Well, even in the first synthetic division, we don't really divide, do we? We just like multiply.
Right, we multiply and add. That's even freaky. But now what's freaky is this process actually gets us the value of a function if you give me an input. Now, it just so happens that the input was -1. That becomes our k value. Look at this. Watch how freaky this gets. I mean, this is so freaky, it's scary. Put your seatbelt on. And you just lost your stamp. Here we go. What was the very first step to synthetic division? What was the very first step?
Bring down the 1.
Gracias. Look at this. Bring down the 1. And now all I do is multiply and add. And watch what happens. -1 times 1 is a -1. Add these puppies. What's 2 plus -1? 1. You're the man. Now multiply again. -1 times 1, -1. 4. We're rocking and rolling, Torres. Now what?
-1 times -4.
Becomes?
+4.
+4. Add those puppies.
8.
Damn, mister, you just had us write all that for nothing.
What's the that?
Well, then you
What do you
guys
mean?
do
What,
it.
wait, hold on. What do you mean?
On the top part, whatever it was called. Yeah.
All this?
Yeah.
Well, it's actually not for nothing. I would disagree with that assessment.
Just had beginning.
But this wouldn't have made sense if I didn't do that first. Think about it logically. If I did this, that would,
I mean, it's just, it's like, it's not,
I don't believe you, Doris.
dividing is harder than like doing that, because that you basically just like, what, multiply or what?
So, are you asking a question or making a comment?
You're multiplying or dividing?
We're not even dividing.
That question, but that question's irrelevant to what I'm trying to discuss.
We're not dividing anything. It's just called synthetic division.
Exactly. That's what I'm
But
talking
But
about.
look at the beauty of it. Ramirez, look at this remainder. Look at the remainder. The remainder is actually the evaluation of the function. It's a quicker way to do it. Whatever you get for that remainder is exactly the output of the function. You take your pick. You can go to the function's inputs and outputs and go step by step, like Doris likes to, or you can go synthetic division and it gets there quicker. So on your notes, go to write remainder. Last part. This is the last thing. Remainder is the output. Put like 2 exclamation points. Like get excited about it. It's a shortcut after all. You can put in 3. Well, you're getting carried away. Stop. Let's relax.